Good morning, Miss. Miss, if you are talking, we can't hear you very well.
Yes, sorry, my microphone was mute. How are you, Ala?
I'm good, Miss. Thank you.
Yes, I will talk because I'm waiting for more students to join because it should be.
Yeah.
It should be.
Yeah, I couldn't come today, Miss, to the campus because I am in the hospital with my parents. They are in the hospital, both of them. Sorry about this, Miss.
It's okay, but today's class is very important because today we will just implement the last part of the previous experiment, which was inductor.
Yes,
And
Miss.
then we will do the revision because that is important for your exam. You're coming for exam tomorrow?
Yes, Miss.
Which time I told you?
9 o'clock, Miss.
9. Okay, 9. Do you remember anything from the previous experiment?
Miss, what exam?
Next week. Next week on Wednesday you have exam.
It's the final?
Hello. It's the final exam.
Okay, are we going to take a revision or are we going to study the whole thing?
Today we will take the revision and also we will complete the last part of the experiment number 6. So please pay attention to this.
Okay, do we have to revise the whole experiments? The whole
Yes.
6 experiments?
Yes.
Okay.
So just 10. We have 10 students and then 30. Half students are not here.
Miss, what time next week?
Next week at 11. I will divide you in 2 groups, 30, because your class attendance is 60 students. So if I see here, what I will do is I will divide you in 2 groups. So let it open. So I will post your groups on Moodle. 30 students will come from 11 to 12 slot, and then the next 30 will come from 12 to 1. So half student, they will sit here, half student in another lab next week. Okay. So 15, 30 first group in 1 hour, and then second group 15, 30. So in the next hour. Okay. So yeah, next week. 15 will sit here, 15 in another. So there will be invigilator here and there, and then calculator will be allowed, but mobile will not be allowed. Okay. No. You will do on the computer, and then you should log in here with your credentials, your username, ID, so that when you come for the exam, there should be no problem. Okay. Only multisim. Only simulation, no hardware. Yes. In experiment number 3. Just a second. So, yes. Yes.
Depends on the hardware. That will be included or no?
Possibly not, because you have computer,
Yes.
so you cannot draw it.
Yes, yes,
So
yes.
possibly not. So 26, will the equations be given or should we know it? There are only 3 equations, so you don't have to. I don't have to give you the equations. So first complete this experiment, because you remember that we did in the previous class only with the capacitor. All of you got the results. Okay, so I just give you a brief revision about the previous experiment. So can you see the screen? Yes. Screen is not yet. Yes. Okay. So previously we were doing the experiment. Natural response of RNC. We studied that what is natural response when there is no voltage source here. Then these are energy storage elements. They will share. They will transfer their energy to this resistor. Resistor always absorbs power. Okay. So this we studied in the previous class. So then we had this equation. So we know that when capacitor is charging, the graph is like this, and when it is discharging, the graph goes like this. Okay, so these are two. This is discharging, and then this is charging. So you remember this from the previous class. Discharging And one thing is, so when the capacitor is charging, please look here because this is important. So when the capacitor is charging, my equation is VC into Vs 1 minus E raised to minus V by RC. So this is my equation for charging, and when it is discharging, my equation is Vs into V raised to minus V by RC. So when it charges at this point, so this is this time interval I am taking from the simulation, okay? And then theoretical calculation is in case of RC circuit, R into C will give me theoretical value of tau, and then with the simulation I will check it like this. When it is discharging, so this value is, because this equation is, this number is coming from here. So Vs can be any, but this will give me this number, this equation, and then e raised to the power minus 1 will give me this number. You can check it from calculator also. So these are very important. So when, what will happen, I will multiply with Vs. For example, if I say 10 multiplied by 0.63 will give me some value, maybe 6.3. So I will move my cursor to this number and then I will calculate down. These were the steps you remember. So this is from the previous lecture. So for the discharging, in case of inductor, this will, we will get the discharging time. So inductor, so it will be Vc is equal to Vs into 0.36. 0.36 is coming from E raised to minus 1. This equation. Okay. Then I will have 3.6. I will move my cursor to this value, 3.6 volts. Then I will get discharging time. Okay, time from. Yes. Yes. Okay, so then this is a table to make you understanding. When I put t is equal to 1 into RC, I get 0.63. Okay, then this is percent. I divide it with 100, I will get 0.63. When t is equal to 2, 86%. So this I explained that when t is equal to 5, my capacitor is 99% charged. So this is number when I, for example, here in this case, I take this maximum Vs 12 volt. So 12 into 0.63 gives me 7.5. Okay, then here I put my cursor at 7.58. So this time I will get in the multi-sim window. Okay, so and then this is discharging, same step, but equation is different. Okay, you have to remember these two equations. Okay, then this function generator we already studied in the previous class. Okay, then this was my experiment. So here what you will do, you will put a current drop. If I sit here, I will tell you. So this is my circuit here. So if I delete it, here you can see that this is voltage probe, this is current probe, this is wattmeter. So you just take this probe, and when it is gray, it means it is not connected. When it is yellow, then it is connected. See, now this is yellow. Now I will run my simulation. I get 19.5 milliampere peak to peak current. Okay. In your pre-lab, this is the table. In your pre-lab, I asked for IPP, means peak to peak current, which is 16 milliampere. Okay. 8 volt, this I get from here. If you double click function generator, my this voltage, I explained you before also, VP is equal to 5 volt means how much is peak to peak? 10. So 10 is VP to peak. So this VP to peak I will need for calculation of my time difference, which is VC is equal to Vs into 1 minus E raised to minus V by tau. So this here I will put 10 and then it will be 0.63. 6.3. So these are the steps. So then you will click here, and then if you stop your simulation, this is your graph. Remember, for the capacitor, you have to check this 200 microsecond coordinate scale for capacitor. For the inductor, I will change it. So you will just move your cursor. How much is 0.2 to 6.3, and then you see that this 6.4, okay, and then you see that this tau is equal to 200 microsecond. So if I go back here, so for this I calculated here from simulation is here 200 microsecond by changing my cursor. Then this is from my year R into C. R was 1000 multiplied by this is 0.2 into 10 to the power minus 6. Sorry, micro is 10 to the power minus 6. This gives me 0.2 milliseconds. So this value is here. So I see that my measured and my simulated value of tau is the same. Okay, this I checked in the last class. Then in today's class, we will do it with inductor. So with the inductor, everything is the same. Here I have to change capacitor with inductor, and then I will first calculate the tau value by this formula for the inductor. It is equal to L divided by R. It's given here in the lab sheet also. It's here. For the inductor, tau is equal to L by R. For capacitor, tau is equal to R into C. Okay. So I calculated this. L divided by R give me 1 microsecond tau. Then I measured it from here with this formula. Sorry? No, not 2. Scale value. Yes, this is 2 here. No, this is 1. Because I get this 1 microsecond. So this scale, this cursor you will get from this equation. How? So you will see that how much is 10 volt is my DS multiplied by this will give me 0.36. So this will give 3.6 volt. I will move my cursor to 3.6. If you can see it clearly, this is 3.6. I can show you in here also. So this is inductor. See here. When I run this and take my cursor here, I move it to 3.6. Here you can see 1 microsecond. This value is same with my calculated value, which is here. 1 microsecond. Here I calculated. Clear? Yes. So one more thing for this. Remember, when you are using the capacitor, you have to choose scale 200 microsecond. For the inductor, you have to choose scale 5 microsecond. Okay, then you will get this figure. So please, in 15 minutes, please do this so that we can move for the revision. Okay, in the simulation, only inductor. Then I will help you too. Online students also please do this. And then you should get the same result like me. Okay. Okay. So any questions? Because I think PCs are busy. So the people who have laptop, they can do it. Okay. So this point is very important. Okay. Remember these two equations. Fine. ना use करें. हाँ नहीं चाहिए. It's okay. Online students, can you try to simulate with inductor so that if there is any problem, I can make it clear. You should get these results. Remember that this equation is for theoretical measurement and then this equation for the cursor movement. And then these two equations, you should remember it. I will not give in the exam. I will not give any formulas. You should remember. Okay, these are easy. Yes, this equation and this one. Both these equations, this and this. For the discharging this equation, charging this equation. Okay. So they are written here also. This is for the charging. This is for discharging. Please simulate, online student, please simulate with inductor so that I can, after 15 minutes, I will move for the revision. Okay. So function generator values are these. And oscilloscope is this. Always remember that here you should choose VP here in the function generator. Always remember these values. Okay. Hello, madam. But if you want to do it, you can use my PC. You did it in yes, inductor.
Student here is complaining that in 6 months be done. And he doesn't know how to speak English properly, so he's saying to translate. Yeah, but
There was a problem. I asked, I don't remember what happened that day. It was 3 weeks before.
Miss, I think it's muted again.
Yes.
Yes, now it's okay.
Did you change this?
Okay, you have to put the cursor like this. Cursor. Exactly. See these numbers. These numbers. You don't only have to put this screenshot. You will show me these cursors placement also. Only this screenshot is not. It doesn't do anything. But if you will move your cursor, then these values I am interested. Here. These values I am interested. Not in the screenshot. I don't want only screenshot. I 1,000. 1,000. In exam, I will not mention. Believe me, I will be very strict. Then here, yes. Then here, and then 3 invigilators. Okay. So this is here. You will get the register. Put it here. Then president. So indefinitely. Go here. Go here. So I will start now division. How you will do? How you will do? And then just page. You will download I will give you on this. You will download it. You will have your exam. But remember, equation. If it is RC circuit, AC circuit, then yes, you will say remember that for the RC, I don't need only this screenshot. I need the cursor. If there is no cursor placement, 0. Okay? I don't need only screenshot. I need this. No, I have it here. I have it. Make it here. Make it. And you need make it like this.
Miss, can I share, please?
1 minute. So, this is ground. Ground is here. Then power is and what we this is and then now change it here. Now and then this you will change here 3.6 by 3.6. Because the voltage I multiply this 10 with 0.36 because this is the discharge equation. Yes. Okay. Now this is 1 minus by 1.04 okay, you got L divided by R. Right? L divided by R. L is 1 minimum. 1. I can change the value of the thinking. 7 for my and you know power. Okay, really divided by 1,000. You will make how much? This 10 will go up, it will be 1 micro. This 10 will this minus 3 will go up, 10 will go up, 3 will go up, it will be minus. So this minus will plus with this minus. Now this so any questions, anyone? Did you build the circuit?
So this was,
Did you understand this in the thing? And then see the recording for section 1 also, because in section 1 I explained this in very detail. So here maybe there is something left, but in labs section 1 I explained in detail about this cursor movement. See the recording for section 1. Yes. But if you see recording for section 1, I can make notes again for you. Yes, okay, see. Quickly, because I have to do the evidence. See there, that is the question. So remove this, finish. See here, because I will not help you with that. Believe me, this is function generator. I took it from here. See, I took function generator from here. I took oscilloscope from here. Put it here. Then see here, flip it. Put positive here, negative here. Then positive here, negative here. Positive here. Okay. This is rough circuit. Okay. You don't have lab sheet for how long? You can see it I think 700. So amplitude is 5. This is 5. Okay. So this will stay here. Done it. Change it. Right. This is now you move your cursor to 3.6. Here this is. Okay. Now this is your down. That's it. Yes. I want this cursor placement screenshot in your exam. I don't want only screenshot. I need these numbers. All 6 okay. Remember that in the exam I will need these numbers, not only the screenshot. Which numbers? These numbers. I need these numbers in exam. Waveform and then these numbers. Screenshot. Yes, because only waveform. If your cursor is somewhere here, it doesn't make any sense. It should be at that point where your voltage will come. Okay. Right? Any questions? Any questions from online students? And then do the experiment with inductor and then upload it, because your deadline is this week, lab number 6. So I will start now revision, okay? Mariam, clear everything? Any question? Farah, for you, what is your question? About this, you say that you lost your notes. But only two things you have to remember. This one, I just write it for you. Only two things remember. Here also I mentioned everything, which each simulation. This is, for example, capacitance, right? For the capacitor, you need two values. I will give you this table in the exam. I will ask you to, this should be theoretical calculation from here, from the equation. Tau is equal to R into C in case of capacitor. So you will put it here.
But this measure.
Yes, this is this one. So a bit, yeah, we have to change it. Okay, let me write it. Yes.
Is this on Moodle?
This PowerPoint I will put it today. Practical, and this is simulated. Okay. Okay, now this. Okay, so I will give you table like this. Theoretical here, simulated here. Okay. So theoretical you got from the equation. Simulated you will get your second cursor placement from here. So for example, in this case, my Vs is equal to 10. 10 multiplied by this will give me, for t is equal to 1. It will give me 0.63. But remember, I can change this t value also. This t value is important. If you see here, yes, here I explain this, that when t is equal to 1 means Vs is equal, Vc is equal to Vs into 1 minus e raised to the power. For example, when t is equal to 1 Rc, this will give me 1 e raised to minus 1. 1 minus e raised to the power minus 1 will give me 0.63. This is for t is equal to 1. But I can change it. See here. I can change it to t is equal to 3. Then it will become e raised to the minus 3. Remember to bring your calculator.
However, it changes.
Yes, minus. This will change. This here e raised to minus 3 will give me 0.95. This will change to 0.95. 0.95 multiplied by your maximum voltage 10.
Okay,
So this will here then. Yes, then you will change your cursor to this number.
Okay, but this value will change only the value for the simulation, not the for the
Theoretical, the formula will remain the same. R into C. Tau is equal to RC. This formula will never change.
Yeah.
But this values can change according to this. See here, for t is equal to 1. This is t. T is equal to 1. This is 0.63 multiplied by here. I got is equal to 12. 12 multiplied by 0.63 give me 7.58. So I move my cursor to this number for t is equal to 1. If I give t is equal to 5, then you have 1 minus e raised to the power minus 5. That will give you 0.99. 0.99 multiplied by this voltage Vs, for example 12 volts, give you 11.92. You will move your cursor to that number.
Vs is given.
Vs will be given. Yes, Vs is this one. Vs is here. You will double click this. You will set Vs here. But remember, you will put here peak value. But in the formula, Vs is equal to Vp into T. Okay? Clear? Farah?
V to B, V plus B.
Yes, fast response. Okay, so these things are important. I will not make very difficult exam, but
Not the same part.
Yeah, I can change capacitor value. I can change T value. I can just see these tables. These tables will help you to identify that what is happening. Remember that here V is equals to Vs is equals to 12 volt. Yes, here I wrote it here. Maximum voltage of battery. It's battery. Battery is 12 volt. Okay. So 12 multiplied by this value will give me 7.58. So my cursor will go to 7.58, some value here.
This you will write this one, right?
Yes, I will give you. But I will not give you any equation. Yes. Okay. For the this is for the capacitor, for the inductor, this equation. Okay. Because if you see here, for the inductor, this is the discharging. For this equation will be this one. E raised to power minus T by RC, e raised to power minus 1 gives you 3.6, 0.36. Okay. Inductor. Inductor, yes. And capacitor, this. For the capacitor, this, I will upload this, don't worry. It's written here, capacitor charging. This is inductor. Okay, that's it. Okay, so it's also written here in your lab sheet. This one. So theoretical calculation formula is here for capacitor, for inductor this, for capacitor this. So this is into 1 minus. 1 minus, okay. So it's here. Clear? Yeah. So let's move for the revision. Next one. So lab 1 is Ohm's law. So you remember what is Ohm's law? Yeah. Voltage is directly proportional to current, okay, provided one constant, okay. So what we have in Ohm's law, simple one voltage source, DC voltage source, and one resistor, and then we measure the current, okay. What we do is we build this circuit. For the current, we put the ammeter in series, and for the voltage calculation, we measure in parallel, okay, as we do it here. Then we can change this source voltage from 0 to 4, 6, 8, 10, and then I will get current and voltage values. I will put them here. Then I will take these two columns. Then I will draw this graph. So this linear graph means that Ohm's law is satisfied. Yes. In Excel, yes, in Excel. So this, and then I can change this resistor value. Then you can do this step. I will give you in the exam this circuit without these voltage and ammeter, without this. You should know that ammeter you will put in series, voltmeter you will put in parallel, and then remember, if it is written A here, if I zoom it, okay, I make it more. Can you see this small A here? This is ammeter. Because I saw that some students were putting voltmeter here and then they were getting the wrong value for the current, because voltmeter will not give you current. Only ammeter will give you current. Voltmeter V will give you voltage measurement. Okay. Right. Then this table, and then you can just put the values here. In the next also here, VR, and then simulated calculation, and then measured. That's it. So you, in the exam, you will only have this column. Okay. And then with this also, current also. V and I. Power, yes. Yes. Power is simple. V is equal, P is equal to VI. Or if you want to do it with the simulation also, with the simulation is also is possible. What you have to do is, for example, if I make another circuit, power you can measure from here also. How much is, for example, okay, I take, so please, the students who doesn't know how to put the elements, just from here you take resistor, you click here, you take ground, and then DC source. That's it. You make the connection. And then I go here, I take emitter. So if I simulate it, okay, so it will give me 0.012 per 1K. So if I want to measure the power, so delete this. Here, from here you will get wattmeter, this one. If I ask you to calculate power and put a screenshot, so what you will do, it has voltage and it has current. What you will do is simple, you will put voltmeter here like this in parallel, and then current in series. Delete this.
So I can put meter and voltmeter.
I can see the here, and then this is series connection.
We have to do this or just multiply?
You can do this also. Maybe I can ask you. That's why I'm making it here. It's easy.
I can't use a meter and voltmeter.
You don't have direct this simple. Okay, I repeat it again. Put your wattmeter here. Okay. How you can across this resistor I want. Okay. Okay, across this. So I will put my current in series. This is series. This is series. Current in series. Voltage in parallel. Here. Here. If I take it. Yes. This is voltage in parallel. Okay. Roshni, is it clear? Now if I will simulate it, double click this screenshot with power I need. So it is 144. Sorry.
144 is the power.
Yes, 144 milliwatt is the power. So if I see in my lab sheet, if I have this, if I go down, if I have 1K resistor, yeah, this one. And if I have, but I don't have the results. So this will be the same. I can do it now. So for 10. Okay, so I have to change it to 10. 10. Now this is 144. So if I make it simulated also, let me check for your understanding this, and then I need a voltmeter. Okay, now this is giving me 100 milliwatt because I'm mixing many things here. Yes. Positive, negative. Yes. So this should give me 100 milliwatt. And if I copy this circuit, make a new design. I just want to verify my calculation. Okay, I will just only verify one thing, that Control C. So 10 multiplied by 0.01. This is 0.1 watt. So from here, I got 100. So I just shift from here. So you see this V into I. 10 multiplied by 0.01 gives me 0.1 watt. If I shift it, then if I shift it towards the positive side, then I will get, so it is, so 0.1 watt I get. P is equal to V into I. So it is 10 multiplied by 0.01. 0.01? Yes, 0.01. It gives me 0.1 watt. If I take it to milli, I will shift it 2 points here. 1, 0, 0. 1, 2, 3. Into 10 square minus 3. 100 watt. 100. Yes, 100. Because I shifted 3 points here. So this measurement P is equals to VI is same with this one, 100 milliwatt. This I can ask you. Okay. I can ask you the simulated power and measured power. Theoretical powers. Simulated power is this one. Simulated is this. Theoretical is this. P is equals to VI. Both are same. Okay. Clear? So you need to know. Theoretical means calculation. P is equals to V into I. You get P from here. You get I from here, P from here. Yes, simulated is this. So you can put this screenshot. It will be easy. I will not make very complicated. Small, but concepts you should know. Calculation of current. So that thing. Okay, clear? Mariam, clear? Okay, so let's, Ohm's law is clear. So I will move to experiment number 2. Okay, so let's go to experiment number 2. Experiment number 2 here. In experiment number 2, we verified 2 laws of this Kirchhoff voltage law and Kirchhoff current law. Okay, so what is Kirchhoff voltage law? Sum of all the voltage in a closed loop equals to 0. For example, you have a closed loop. Sum of all these voltages will be equals to 0. And KCL is current entering is equals to the leaving current, sum of leaving current. Sum of currents entering is equals to sum of current leaving. Okay. So what we did in this experiment, we have this circuit. We put ammeter in parallel and just we wrote the values here. That's it.
No need for 2 meters because series and no R3.
Yeah.
Right?
Yeah, because this is current.
R3 and R4 is in the same current.
Yeah, they have the same current because they are in series.
Yeah.
The current is same in series. In parallel is different because this is a parallel. These two are parallel with these.
Yeah.
So we put here. Here only one because current will be same. Even if you put this ammeter here, it will give you same reading. If you put it here, same reading. Okay, anywhere. Then this is the current, and then here you see that I put all the voltmeter in parallel. And then what I can ask you to verify KCL and KVL. How you will verify KCL? Sum of all the currents entering is equals to, yes, that one, and then loop equation by mesh analysis.
Yeah.
That's okay. Equals to
Miss,
0.
I have to write it in the numbers or just the equation I have to write?
You will get the numbers here.
Yeah, about the question that is using the measure values in table 3. So I have to write the numbers with the equation, right, Miss, for the KCL equation?
Yes. KCL equation is
Okay,
KVL equation is this one. Equation is here. Yes. KCL equation is this. KVL is this. Okay. And
Okay,
then
Miss.
you know that in this circuit we have 2 loops. So you should write loop 1 equation, loop 2 equation, and then you will verify. Okay. Because sum of the voltages in this closed loop equals to 0. And then sum of voltage in loop 2 is equals to 0. 2 things you have to. You should get 0 in both cases. Okay. Any question from experiment number 2? Also, you see that you calculated here equivalent. So this was something else, but I can give you this kind of circuit and ask you to calculate the equivalent resistance. You know that how you can find equivalent resistance for this? Yes.
That is the parallel together, right, Miss? From the equation.
See this R1, and then these two is in parallel, plus R3 parallel with R2 plus R4. This will be R1, R2 divided by R
Plus R2.
plus R1 plus R4. Put the value. You can do this by simulation also.
And the second sometimes it's that sum of the positive almost zero.
Yeah, almost 0.001, 0.01 like this.
In the simulation, I will put how?
Just short circuit. Just short circuit. You remember that how I explained you how to calculate the Thevenin resistance? Same thing. I short circuit everything. If I want to implement this circuit, okay, I can implement it. So if I take a new design, okay, so
And the two terminals, I will put the multimeter.
ohm meter. Ohm meter. So let me, I will 1, 2, 3, and 4. Okay. This was parallel, right?
Yeah.
And this was parallel. This was here. Like this. Because I'm making very bad drawings. How you will, so okay, let's suppose all are 1K. Just short circuit and measure here. Take from here multimeter.
Yes, multimeter.
So remove this.
The two terminals, I will
Yes, series connection. Okay,
see.
series. Okay, then
Put it on.
ohm. 2.5 kilo ohm. You can calculate this with, for example, if I can calculate, it will be 1. This will give me, I think, 1 kilo ohm. Half. So it's the same. So same this. So you can now. Did you get the concept?
Yeah.
Yes, Miss. So it's never mind any one of them. It
I
will
will
be
write.
connected to the plus and minus.
I will write the equation. 1 minute. Because this was the same. I have R1 1 kilo 1K plus 1 into 1 divided by 1 plus 1. Yes, this will be half plus 1K. So this will give me 1000 plus 500 plus 1000 2.5K. Here I got 2.5K. Okay. You can do this kind of things. But remember,
Yes,
you will
miss.
put ohm meter in series. Okay. Clear? I
Yes,
can
miss.
ask you this also. Okay. These things are very easy. So anything from here, lab number 2? No question? So I will move to lab number 3 now. Lab number 3 is this. Okay, nodal analysis. Do you remember what is nodal analysis?
Yeah.
So we were measuring the node voltages at the terminal, at the node terminal. So why we were doing this? Because you know that you can find, if I ask you to find current here, what you will do, VN1 minus V1 divided by R1. This will give you current here. Okay. If I ask current for all this node 1, then sum of entering currents will be equal to leaving current. So this equation is coming from there. Okay. So what you will do for measurement of nodal voltage, you will, the purpose is to get the current across this loop. Okay. So what I will do is, here for example, this is my experiment. How I measure node voltage, I just put voltmeter here, one terminal positive here and then other with the ground. This will give me node 1 voltage. But remember, you have to put exactly at this node. Not if you put this terminal here in between, it will not give you node voltage. Node voltage you will measure only at this node. Okay. And then you will write the values here. Node 1, node 2 voltages, and then currents. Currents, how you will measure? Currents only by this. Simple. Very simple experiment. Clear?
Miss, can you repeat again, please?
So I said that if I give you this kind of circuit, so let me open this.
I will put the voltage and then in the nodal, right?
Yes, go to the slides also. See here. So how I measured the node voltage? I put one terminal of this voltmeter here, negative with the ground. Okay. Then I measured 5.9. This is my VN1 voltage at this node. Then voltage at this node, same procedure here. Then currents, how I measured? Series connection of this. I put all the emitters in series. No. I will not ask because for this I don't think it's not needed. Yes, that's it. Because we did the same in the lab. We didn't prove any equations. I will not ask you any equations. But these simple things I can ask you because they are only small formulas. Okay, these simple things I can ask you. But for this, I will not ask any nodal equation, any mesh analysis. I will not ask you. Okay. So then, clear lab number 3? Okay, lab number 4. So in lab number 4, superposition theorem. Do you remember superposition theorem? Yeah. What we have 2 voltage sources, and then we ask, okay, for example, I have one element. For example, if I have 2 sources, VS1, VS2. What will be the voltage here? The voltage across R1, for example, this is R1, is equal to VS1 plus VS2. Yeah. It will be collective contribution of both sources. So for the superposition, first step will be, I will remove this voltage source and then I will only measure the voltage due to this one. So first step, remove VS1. Second step, remove VS2. Then measure, put this back, measure the voltage. At the end, you will just verify this. And also, you will put both of them, and then here you will put the voltmeter in parallel.
It should be the same values.
Yeah. This should be same.
To verify.
Yes, verify. Yes. Because if I will not ask about verification, then superposition, how you will know that? Yes, but verification is also so that because if you will put this VR1 plus VR2, this will give you exactly the same voltage if you will put both of the sources together and then measure. Clear, Mariam? So these things are important. So for the superposition, remember the steps. So for the superposition, remember the steps. So let's come here. I think in my slides it was more clear. So here, what I did, I have both the sources here. Now, for example, if I want to measure voltage across this will be the collective sum of due to 8 volt and due to 5 volt. But then what I did is, here I removed 8 volt. Then I measured this is 0.392. Then I put back 8 volt and then remove 5 volt.
Also the current is same.
Current, I'm not interested, only voltage. Current maybe you can, but
The same you could
current will be the same. So it will not matter. Only voltage will be different.
So, Miss, we're gonna do the
But-
both.
Yes, for the current also same thing. Same
just
thing.
to remove the voltage source
Yes,
and
yes,
take it to
yes,
the-
yes. It will be different. And then sum of both currents will be equal to the collective.
Yes.
So in the second, I removed 5 volt. Then my current, then my voltage is 2.696. 2.696 minus 0.392. You can do it in calculator here. Two point six 2.696 minus 0.392, 2.304, and then go back. This is 2.303 when both sources are connected. This is the verification. Okay. So only 3 steps. Removing the first calculating with both voltage sources, then removing one source, finding the voltage, removing other source, finding the voltage, and then summing up, and then prove that this is equals to the collective. When both sources are connected, this will be equal to the individual one. Okay, sum of individual. That's it. Okay, clear? So I will move for the experiment number 5. If you have question, ask me.
We want to visit about and
6 again?
yeah.
Okay. Okay. 6, I will, yeah, I have time. So for the Thevenin, what is Thevenin theorem? Do you
Theorem
remember?
is easy, I think, Miss. It's the easiest one.
Resonance and load.
Yes. So Thevenin also we will follow some step as the superposition. So you are laughing. So what you will do, I will not help you in exam. Did you understand superposition theorem? Yes. How? What are the steps for superposition theorem? So, okay. What happens? We have a very complicated circuit. We transform it to this simple circuit, which has only one voltage source, one equivalent resistance, and one load resistance. Okay. For example, we had this circuit. So, what were the steps for this? I wrote here also.
Yeah, we will remove the voltage on once and we'll make a shortcut.
First of all, the first step is removing the load resistance.
The load, yes.
Yes. Then finding the open circuit voltage. Then finding the short circuit current. Okay. Then finding R Thevenin and then simplifying. Okay, let's see here. This is my.
When I want to get the R Thevenin or the V Thevenin, I should remove the R load both in I and I.
Sorry, again.
When I want to get the I
Yes.
and the V,
Yes.
both I will remove the R load, right?
Which I, because it depends.
R load.
Yes, R load, I will remove this. So my first step is I will remove this load. Okay. Then I will put here 1 voltmeter in series. That will give me open circuit voltage.
A meter.
No, voltmeter.
1 meter in
Okay,
series.
in series, yes. Here, this procedure is this. You will put here in series
Why in series?
because that will give me open circuit voltage. Because we don't have switch. How we do open circuit? In online multisim, I can do that. For example, I want to measure here open circuit voltage. Here. What I will do, I will put my voltage probe here and then I will open this switch. For example, this is ground. But in this, I don't have the switch. So that's why I will put here voltmeter in series, but this will give me the same voltage, Thevenin. Yeah, we did it here. Let me, I will do in multisim also. 1 minute. Where is that? Yeah, this one. I put voltmeter in series. Check this. This will give me open circuit voltage. Okay, this is the procedure. Then I put it here, 3.181. Now this is my Thevenin voltage. Okay, so the voltage sources are there. I just removed RL and then I got this voltage. I put it here. This is my Thevenin voltage. Then I calculated R Thevenin. How? By removing these voltage sources, both of them. Then here I will, by this procedure. So just I remove voltage source from here also I removed, and then I did the same procedure. I will I put here in series ohmmeter and then I calculated Thevenin resistance. This is my second step. Okay, then my third step is, yes, next. Okay, I explained it here because I did it in another class. Yes, so this was my, okay, I remove this. Here I calculate 3.122. This is my V Thevenin. V Thevenin. Okay. Then what I did is I removed, I short circuit. How do I short circuit? I remove this. Short circuit. I remove this. I remove this also. From here I take,
In series, right, miss?
yes, series.
Uh,
1 minute.
exactly what you put to
Sorry, what?
the terminals.
Which positive with the positive side. Ground is always negative
Okay, the next with the always the
with the ground. Negative always goes to ground.
okay, and the positive.
Positive with the terminal where you want to measure. Because you remember I had my wire here. I removed that. I put it in series. I go here. 1.019 kilo ohm. This is my second step. Okay, first step was simple. Okay, this was my second step. Farah, it's not clear. Actually, here we don't have the switch. I know. Here we don't have the switch. If I go to here, what will the procedure? Okay, I open multisim here. Because with online multisim, you can do it.
Miss, I wanted to ask you a question. Is the exam going to be with multi-sim?
Yes, with the multisim.
Okay. Do
I
we
will
have to
make-
bring our laptops?
No, you will have the desktop here.
Okay.
Farah, I will explain you here. So we have, okay, how many resistors we need?
We need 3.
1, 2, 3, 4. Okay, RL we will not put. 2K, 3.3, 5.6. Yes. Yes, this one, not this one. This I just want to clear her point. So then 1, 3. What else? That's it. 10, 5. 10, 5, 10. Okay. Two and 3.3K. Now, what I will do is, if I want to measure the open circuit voltage, I will put a switch here. Make it open circuit. Here, what I will do is, I will take a voltage probe, 10. So this is 5.6. 5.6K.
So we can remove the wire.
Which wire?
So that it was open.
3.3K. This gives me 8.8. 1 minute. 2K. 2, 3.3. 5 volt, 10. Actually, this is the exact procedure to do it. But here the value is different. Actually, I asked the professor also who designed this lab. So this is also my point, that why we are putting, yes, because in series we are getting the voltage, but just go with the lab sheet. It's fine.
Only this experiment.
Only for this experiment, only put voltmeter in series. This is the exact procedure. This is the exact procedure, but there we are doing this because there is no opener. This is short. This is the exact procedure. Now this is mine. Yeah, this is open. This is open circuit. This is VThevenin.
Yes.
But here in your lab sheet, this is in series. So we didn't like. For this, just remember you have to do this procedure. So I will discuss it with the professor and then we will clear this point for the next class. But for you, it will be the same. But exact procedure is this. Okay. Here, this is not open. This is not open circuit from anywhere. So just remember that. Okay. So first step is finding the voltage like this, then putting it here, then finding the Thevenin resistance from here. Okay. And then finding the power from simulation, and also with P is equal to I square into R. What you will do is you will put back everything like this. You will measure the current. Okay. You will measure this current 1.577. This multiply with the voltage will I square into that load resistance will give you power, not voltage. Only you can use I square into RL. Or voltage with R. V voltage with current. V, yeah, VI will give you power, and I square into R will give you power also, and then V square divided by R will also give you power. Maybe this I can ask you because we did it in the class.
Very complicated.
This not complicated.
Here,
Here
because we have
only just remember that current we are calculating here. Series here, parallel here. Yes. No. Voltage always in parallel, but only in this experiment. Only here. Okay.
we put back the resistance.
Yes, for the final calculation, you put back the resistor here. Then emitter here. Across the load. So this is RL, remember. If I give you any circuit, for example this, and then I can put RL here. So this will be your RL. So you will measure current in series here, voltage in parallel here. So P is equal to VI. In the beginning, you will remove this resistor. I will put RL. Remember that
You will determine.
yes, I will write RL. Means this is your load resistance. So you will do all your experiment across that resistor. You see, there are other resistors also, but we are doing our measurement only with this because this is load resistor. Now I have my open circuit voltage, which is V Thevenin, which is here. I have my R Thevenin. I can transform this into a small circuit, which I did here. Simple one. No, not this. Yeah, this one. I got my open circuit voltage 3.181, 3.18 here. Then R Thevenin was 1 kilo. I calculated from here 1.019. Then I measured the short circuit current.
You will ask us for P7.
Yes, yes, that is the
same
steps.
of the RL.
V
Of
Thevenin.
the RL.
V Thevenin, that you have to. No. P Thevenin will be the same. For example,
Same of the
R Thevenin. R Thevenin. See, I can P Thevenin I will not ask. That is not needed. P Thevenin I don't ask, but I will ask this table.
Yeah. Okay.
Only 5 minutes, and then we are finished. But we have to do experiment number 6. Okay, just go in because we have to do experiment number 6 also. Now you see, I got my value, this V Thevenin from here by series connection. Then I got my R Thevenin from here. Then I put in this. This table is important. Now my final circuit will be made up of this. See here, 3.18 and 1K, and then this RL I can change. If you see this one, here RL I change. Now I simulate this. 2.164 is my current reading. Go back here. How much is my 2.136 here? So if I change it here in the original circuit, so I remove this. Which circuit is running? It will be the same. I will check it now. I removed everything from here. So
I think it will be I short circuit.
short circuit, yes, yes. So see, I will check it now. And this was my original circuit. Okay. This voltage was, I think, 10, 5. And this is my load.
You want to measure this one, right?
I want to measure the current. Power I will do by V square, I square into R. So I put one ammeter, this one. Five. This is how much I put here. 1K? No. 470. This is RL. 470. I will put here 470. I just want to make sure my calculation. 2.136. 2.164. Almost the same. Okay. So this I verified that I can transform my complicated circuit into the smaller circuit, and then my results will be the same. Okay. This one. I put back RL. This is emitter. Yes. So I am measuring the short circuit current, okay, across the load, or I can say it load current because it is across the RL.
You put the RL and then.
I will put RL, for example. Yes. See, this is RL. So you have to see that which is RL. So you have to perform all your analysis on RL, not any other resistance, only RL. First step, you will remove this. Step number 1, remove this and put a voltmeter here. That will be VThevenin. 1, okay. Step 1, remove RL. Find VThevenin. Okay. Step 2, remove this. Put ohm meter in series to find R7. Once you have these two, you can make your circuit. VThevenin, R7, and then you will put breadboard.
No need for the argument.
No, that's not needed because that is not really important for making your simple circuit. But I can ask you to find IL. Load current. Okay. I7 we don't need. VThevenin we don't need. For the simplified circuit, we only need VThevenin or
If you want IN this way, right?
Yes, this is IN. Load current.
Okay.
So I can ask you to find the load current for different resistor values. For example, 470, 1K, 2K, 3 different load resistance values. You can find load current here. You can find load current in the Thevenin equivalence. And then calculate power.
It will be the same.
Power.
Will be the same. If I calculate
Same both. Find power with this. Find power with this. Okay. 30 marks question. Okay. This question will have 30 marks. Okay. Easy? Yeah. See this. Correct? Clear? Roshni, clear? Only remember the steps. Okay. Now, then you can do this. Okay. Then, last experiment. Everything is here. Okay. Last experiment is experiment number 6. I think you are already
Miss?
familiar with that. Yes.
Miss, you will upload this one on the model and also the recording for today.
Yes. And then
Okay, miss.
also when something is not clear, because in section 1, section 2, I am explaining different things. Like same thing, but students are asking different questions. So if some point is not clear, you can go to the recording of other section. Because all 1, 3, and 5 sections are with me. Okay. So last experiment number 6. So this I think you are already familiar. Or should I explain it? Okay, where did I put my pen? Okay. So this experiment was the same today I explained. So this experiment is 2 things here also we have to, this you know that these elements, they are storing energy and delivering to the circuit if there is no voltage source connected. So here, for discharging of capacitor, my equation is this. For discharging, equation is this. This will go in. Yes. Okay. So this is my equation. It's very hard. This is my equation for charging. Okay. You know that capacitor gradually charge from 0 to the maximum value. Gradually it will charge. Okay. So when my equation is this, when I have V C is equal to Vs into 1 minus e raised to power minus t by tau. Tau for RC is RC circuit is equal to R into C. Okay, first I will calculate my value with this. For example, I have 1000 multiplied by 0.1 microfarad. Micro means 10 raised to power minus 6. This will give me 0.1 millisecond. 3 will cancel with this. Okay. So then from here, when t is equal to 1, my value is 0.63. I will multiply it with source, maybe in this case it is 12. 12 multiplied by 0.63 will give me 7.5. Then I will move my cursor to this number to get tau. Tau will be this. Clear?
There is no, this is should be T, right? In the table, not
Which one?
in the table.
In the table, this is T. This is T. I had to change it. Not tau. This is T. Okay, for the negative. For the negative value, negative means discharging. My equation will be this: 1 minus e raised to the power minus t by tau for charging. For discharging this equation. Okay? Then t is equal to 1, Vs into e raised to the power minus 1. E raised to minus 1 will be 0.36. Multiplied by 12, this will give me 4.42. This value. I will move my cursor to 4.42 to get this out for discharging. We did this in case of inductor. Okay? Clear? Yes? So let me erase this. And then if I ask you to find the peak to current, then you have to put a current probe from here. If I go back here, current probe I take from here, this one. Remember, when it is gray, there is no connection. When it becomes yellow, then it is a connection. Okay, remember, if it is gray, no connection. Now this is yellow. Now it is connected. Okay. So peak to peak is here, 19.5 milliampere. Okay. So for this only, this waveform is important. And just this one. And then with the cursor placement, according to Vs. Okay, according to charging, according to discharging, and multiply by Vs. Vs you will get from here.
Miss, can you make it again, that one, the running, this one, because I didn't know how to make it. Because I make the run, but I didn't see it from the telescope. I don't know what it's called.
Oscilloscope.
Yeah, this one. How do you make the running? It will be from this one to show this one, not to show the other
You
one
have
result.
circuit. If you show me your screen, I can fix it.
Okay, I will log in now. Just one minute, miss.
For the minus, yeah.
Next Thursday, what you will do with the lab? You have exam on Wednesday. Yes, I can. Come to me. Okay.
Miss, can I share now, Miss?
So, okay, for the students here, please tell me your IDs so that I can put the attendance. So that's it about the revision. Hopefully everything is clear. Okay.
Can I share?
Oh yes, okay. Share.
Can you see, Miss?
Yes, yes. I will take your control.
Okay.
So what is the problem?
The problem that I want to take the running from the telescope from this one, not from the OMO. Yeah, I don't want to be like yes.
You have it, but I think you simulated it through here. Don't simulate it from here. Directly run it from here and see your results.
Mhm.
Interactive.
Oh, I have a problem on the Zoom.
Very slow. Yes, okay. Let's see. So, okay, let's check here. 550. Okay. It's very slow. Yes, you get it now. You just have to pause it. And then go here. See, this is your waveform. Now you will move your cursor. Okay?
Okay, Miss.
Good?
Thank you, Miss.
Yes, no problem. And then stop sharing. So I will write the names for the students here. Yes. Please come and write your student name, and then that is it for today's class. Reviewing everything. Only number one. Okay. Over. If you help yourself, you will get it. By your own effort. I will not help you. You were laughing me. I saw you. Okay? That's it. License. Just tell them to come here. No, not SIS. Yes, I'm there. No, not there.
داش 48 11 كم؟ 5 لا بس 3 5
Try to perform good in your final exam, okay? If you get 0 marks, I will give you 0 marks. 0, 0. If your exam is for 0, I will give you 0. I will not listen to you. You are laughing here. I saw you. Okay. So, online student, this is it.
Yes,
I will
miss.
take your attendance. I will take your attendance from the SIS, from the Zoom. So, yes, equations. I will not give you any equations. So you have to remember the equations, okay? It's
Okay.
easy. Only 6 experiments, okay?
Inshallah.
Okay. See you. Allah, see you tomorrow, and then see you all next
Inshallah.
week. Okay?
Thank you, miss.
Bye-bye.
Bye bye.